Hello, everyone, and welcome to this newest edition of the virtual IoT meetup. My name is Frédéric Desbiens. I'm the program manager at the Eclipse Foundation for IoT and Edge Computing. So today we have a very special thing, a presentation from our newest member of the Eclipse IoT Working Group, Cedalo. So with me are Philip Ackerman and Philip Strauss. Welcome, guys. So if you want to introduce yourself to the audience.
Yes, hi. We're really excited to be joining and to actually also present our open source technology, Streamsheets. I'm Philip. I'm the first of us, so to say. I'm the one of the founders and CEO of Cedalo. And really just a quick introduction to me. Yeah, Philip, what do you want to take over?
Yeah, my name is Philip Ackerman. I'm the CTO of Cedalo AG, and yeah, I'm a computer scientist, and before joining Cedalo 2.5 years ago, I worked over a decade, I think, at the Fraunhofer Institute in Germany, mainly in the area of accessibility and web compliance, and later with a shift to IoT and industrial IoT, e-health, and yeah, such things.
Excellent. So you're the one writing among the ones writing the code for your product, right?
I'm one of the I'm one of the developers here in Cologne. So the development team is based in Cologne, in Germany.
Nice, fantastic.
Exactly. Maybe really shortly also to Cedalo itself, we're about 10 people, mostly in Germany, in Freiburg, so that's the southwest of Black Forest, and Cologne, that's the bigger city, so to say. The other Philip with 1 P, he's in Cologne, and I'm with 2 Ps, and I'm in Freiburg. And mainly in Germany, because we have also Roger on the team, the creator essentially of Mosquito, and he's based in England.
Yeah, absolutely.
Exactly.
Hopefully Brexit will not get in the way of your fruitful relationship with him.
No, we don't think so. If there's anything happening, then we're just going to put him on the next boat and basically carrying him over.
Fantastic. All right, so our presenters today asked me if you have questions, they will answer them as we go. So please use the Ask a Question feature of Crowdcast to do that. And then when we have questions, I will interrupt them and ask them the question that you will have asked. Okay, so let's go on with the presentation now.
Okay, nice. I'm just going to take over here then. So,
fantastic.
So there we go. Really quick introduction, basically in PowerPoint as we see it now, and then of course we're also going to go later on into the product to see it itself and how you can essentially build something with it. So the program itself is Streamsheets, and it almost says it all. So we deal with data streams coming essentially from anywhere: sensors, machines, websites, databases, anything. And the goal is always to build an application that deals with those data streams, merges them, visualizes them, or stores them. And all of this logic that's necessary there, you essentially build in a sheet. So we basically come from the idea, or a little bit the way how we see the world is everything is an event. So everything is event driven essentially, whether it's an order, whether we have sensor readings, for example, invoices are being sent, a machine moves, anything basically happening in an application or being pulled, for example, from a database. Are events, and if a couple of those events happen consistently or regularly, an event stream is created. And as I just said, the idea is basically to merge those streams, to process them, to visualize them, to store them, to really just somehow manipulate them and do something with them. And Streamsheets, basically the main idea behind, or one of the key ideas behind it, is that if you want to do that, you typically have to be able to code. Typically in one of the common programming languages. It basically doesn't matter which one, Python, JavaScript, Java, whichever. Please don't look too closely at the code. I know it doesn't make sense, but it's just to basically fit the screen nicely. And the target users which we have essentially are exactly people who don't know how to code. So essentially process owners who understand how a process works. Typically so far, these are, for example, quality or process engineers essentially working on the shop floor in the production line. So they understand the machinery, they understand the production line, read the process behind that, and are clever, although they don't know how to code. And what they typically feel comfortable working with are spreadsheets. So typically, this is Excel, but can also be Google Sheets. Essentially, it's just a spreadsheet. And the idea now was to provide a user interface that people know already, so a spreadsheet essentially, that lets you build applications that deal with those data streams. So essentially, it's a really strong code converter. And that's the main idea behind it, to be honest, already right there. So we have a message stream and event stream coming from essentially anywhere and going anywhere. And the goal is to build an application, but instead of writing lines of code, we're essentially just going to fill cells with formulas. And what pops out during the process already is an application or a microservice running on a server. The server can be on-premise. It can even be running on the edge. So Streamsheets also runs on the Raspberry Pi, for example. But of course, it can also run in a cloud cluster. And yeah, that's about it. And the idea how data is getting into the sheet to being processed is essentially via a couple of protocols which we support. Like the most common ones are probably MQTT and then HTTP, so meaning essentially REST requests. Or we also support OPC UA, especially very interesting in the industrial IoT, so where you have a lot of machinery and want to connect PLCs, for example, but also AMQP, Kafka, or UDP right away. And the thing is that we are also quite extendable on which kind of protocols we support on the ingestion as well as essentially on the publishing side. And really nice to note here as well is we are not only subscribing to data or can take data, can consume data, but we can also provide data, send out data, so essentially produce a data stream as well. And well, the main idea behind it is really to empower those people who have process knowledge but are hindered or can't code or can't implement it or pour that knowledge into an application themselves because they essentially lack the tools or the skills, the programming skills. And what Streamsheets on this side basically brings that you know already how it works, because you're going to see in a second as well, all the formulas there, they work the same way as they do in Excel, for example. So some formula or VLOOKUP or all the other ones, they take the same parameters, are called the same way. You build very interactively, so basically you see after each cell you fill, not only what is essentially the result or the output of that cell, but also as new data is being generated, all these cells are updated. So you really see the whole thing in process, essentially. And the main goal behind it, or one of the main goals, is you save time and so you save costs, because the people who actually have the process knowledge and who otherwise have to write the specifications anyway, they just gonna figure out what the specification actually has to be or should be. And as they go along, they also right away build the application. Yes, so I'd say that's it already from the PowerPoint side. And I now dive basically into Streamsheets itself and show you a little bit how the application looks. Is there any questions so far? Just checking here the chat. No, it looks good so far.
Yeah, you've been pretty clear.
Cool. I hope so. Yeah, that's typically that's a sign of being either quite clear or not clear at all. And I hope it was the first. So if everything works, you should see now a Chrome browser here, and the Streamsheets application open already. And as you see at first sight, it should look exactly like more even Google Sheets than Excel. And if you look a little bit closer, there are a couple of differences there. So the main difference being, for example, we have something here on the left-hand side, which is called an inbox. And that's essentially where we get the messages in. So I've already connected now an MQTT stream. So we are subscribing to a topic here and getting data in. I'm just going to click on go or start the machine essentially. And now we're going to see that the message ID here is changing the whole time, and that also the values which we get in the payload changed the whole time. The first step now, really, what do we have here? We have messages coming in from a topic, essentially. And the first thing you hopefully notice is that you get full transparency over what kind of data you're actually getting. So over the payload, how it's structured, what it actually contains. And what you see here is native JSON objects. And the nice thing is you don't have any parentheses or in any kind of commas or whatsoever, but everything is nicely formatted so that even an end user who doesn't necessarily know already what a JSON object is just sees a nicely color-coded hierarchy, essentially. And that's what you get there. And then you really start working with those values. So for example, let's say we get here a machine data in, just drag and drop that into the sheet. Now we've made a direct connection between the underlying data stream. So essentially anything that happens on the broker and is being sent to that topic that we're subscribing to, and the sheet. And the sheet itself, we're now going to start building a logic, how we want to deal with those values and what the application is supposed to do. So something really simple would be, for example, let's assume we want to calculate a very simple KPI. So that could be, for example, the sum over all the values which we're getting in here, which is essentially B3 to B6. Huh, that's not interesting. Range B3 to B. There we go. Okay, and as you see, we basically type in and have the same formulas as we know them from Excel. And once we hit enter, it not only gives you essentially the result, but it is also now being fed continuously with the new data and updates the whole time. And that's what's happening here. So we have a formula in right now calculated continuously. So next thing could, for example, be to build a small history over these values, just to make sure that we store them somewhere, and possibly we even want to visualize them. That would be working basically just by referencing this value and now referencing downwards. And now we're going to leverage one of the characteristics of Streamsheets, and that is that you have a predefined calculation order. Typically, it happens via a natural order, so to say. Essentially, in Excel, you don't know in which way this is exactly done. In Streamsheets, you always know that. And that is essentially that the first row is calculated first from left to right, and then the next rows are calculated. So from left to right and from up to down. And that's also what we are leveraging right here, actually. So we are linking to this value, to this KPI, which we're continuously calculating. And then we're just referencing downwards, meaning that any of these cells is always referencing one down. And as you see, is that all the values which pop up here are moving up, essentially. So this way we can really quickly, for example, just store the last, in this case, 32 values in the sheet. And if you want to visualize that now, you can also do this really quickly in a kind of way which you already know from other spreadsheets. So really just clicking on the icon up here and then putting it right into the sheet. And then you can change the types, for example, off chart, which you want to visualize. And of course, can start really quickly also giving it, for example, tasking, working group, giving it title. So really work with it in a kind of way which you already know from another spreadsheet. But as you see, everything is automatically dynamic as it's being fed new data and it's updating. And yes, so that's really how you work with it in a very Excel-like kind of way. And if you were going, for example, for a dashboard, essentially you can really quickly, for example, also blend out all the components you see here. So take away, for example, the inbox, the grid, or the headers, and then you rearrange it a little bit. So essentially you would later on probably drag that over here, or you would put them down somewhere else, so that you essentially in the end only build a dashboard. You can also take away, for example, this part up here, and then you necessarily don't even see anymore that you've built that in a spreadsheet.
And it looks we have a question, Philip.
Yes, of course. Go ahead.
So we have our friend Benjamin Kebe asking,
Hi.
any reason why not integrating natively with Excel or Google spreadsheets through their respective APIs? Or maybe that's next in the presentation.
Yeah, unfortunately, it's not coming in a presentation. Yes, we've been thinking a couple of times about that, and something to a certain extent is on the roadmap. But the thing is, what you notice if you work with Streamsheets is that you typically do something else than you do with Excel or Google Sheets, especially if you compare it to Excel. Excel is very static. You typically use it for reporting. Otherwise, you're really manipulating it quite a lot to make it somewhat dynamic, and that's essentially writing a macro in VBA. But apart from that, it's really something static where you have hundreds and thousands of rows which essentially contain the same formulas and the same information. In Streamsheets, you really build an application that is consuming or that it's processing this data. Essentially, if you compare it again, those rows of data, as they are being created, generated, you calculate them right away or you process them right away. So in the end, although the way you're building logic is very, very similar, what you in the end are doing with it is different, because it's not so much a report, but rather really an application which processes real-time data. Exactly. So it makes already more sense to connect it to Google Sheets in a certain sense, because they have that to a certain extent, that they can recalculate some of the formulas as well. But so far, we don't have a direct connection with that. But you can, for example, export something here or write a file, a CSV file, for example, which you could then import in Excel as well.
All right, that makes sense. And just a reminder to the audience, please feel free to ask questions as we go using the Ask a Question feature of the platform. All right.
Exactly. So what else can you do? Basically, just to work along this very, very simple application here a little bit more. So what we're doing currently is we're calculating a KPI, which is essentially the sum of those values. So very, very simple thing. But now let's assume, for example, just to make that a little bit more clear, let's assume we have a threshold, which could be in this case be, let's say it's like 1,100. So just type that in right now. All the formulas are recalculated. And why is that so interesting? That's really interesting because also all conditions are checked and checked again. And in this case, we are looking at the status of whether our KPI, for example, if our KPI is larger than the threshold, and if it is, everything is okay. And if it's not, it's just not. So not necessarily looking at how much sense the KPI makes in itself and how it's being calculated, but just looking at the idea behind it. So the KPI is continuously being recalculated. We have a threshold, which I should have put at a different value. So just going to do that really quick. And we are having basically a status, which is looking at those two and just checking the whole time whether something is okay or not okay in this sense. And as you see, also these conditions are being really calculated, and depending on that, this cell essentially changes. So it's quite nice to have that now here in the spreadsheet, which we can look at. But the real cool thing, or the real next cool thing about that, is we can really take decisions depending on these values. So we have JSON, for example, coming in, and now the idea is really to send that out, for example, again. So we're working in a spreadsheet, but we want to send something out to another application, back to wherever this is coming from, for example, or to notify somebody via mail. So essentially, it's just to publish something, to send something out of the sheet again. And even if I don't know what a JSON object is, I know I get a nicely color-coded hierarchy in, so that's probably what I want to send out again as well. So let's just see that this is our result. And now we basically want to convert this into a JSON object. So that's really simple to do as well in Streamsheets, right in the sheet. I just right-clicked. Now you're going to define a JSON range, and there we go. We already have a nicely color-coded not hierarchy, but object or cell range essentially. And if we want to structure this now, I just gonna click tab now. There we go. We're already building our hierarchy. And as you see, all the formulas, they're still working, but at the same time, with every calculation step, we are essentially sending out, not sending out yet, but creating a JSON object. And if we want to send this out now, there are a couple of possibilities on how to do that. So of course, we have like typical functions, which you see here. These contain essentially the most common one contain for engineering, logical, math, statistics. Most of them you already know from Excel, for example, but there are also other functions, and these are the stream functions. So for generating a data stream, these include, for example, then really sending out something via Kafka, storing something in MongoDB, sending out something, publishing something via MQTT, making a REST request, sending a mail, or really writing into a file, for example. So let's just take MQTT to stay basically in this protocol. I haven't chosen here MQTT, then I just gonna choose a connection which I've set up. So essentially behind that is just a connector which I configured. So in this case, it's really just the URL and the credentials, and there we go. That's really just what's behind MQTT producer. Then the function itself already looks at the last JSON object essentially in the sheet. But of course, this can also be like any other cell range which I want to send out. Then we're going to go to a target topic, for example, target topic, click OK, and there we go. We already have that in the sheet. I see that everything basically right now is colory already on the sheet, but it doesn't get any more colory than that if you want, unless you want to. So like all the special things, they're colorful. So the JSON objects which you drag and drop in, the ones you create right in the sheet, and the stream functions which you have. So it's blue down here, but if I click on it, you should see up here that it's just another spreadsheet formula, which is new. So you won't know it from another spreadsheet application, but it also just takes 3 arguments. So it's really simple to learn because it's really just what we typed in. And a really cool.
And to me, this highlights an interesting thing about your platform, because you're positioning this really as an end-user tool, code-free tool. But I mean, people that are knowledgeable about Mongo and MQTT and all of that can leverage the platform to do stuff like what you just described. I wouldn't expect an end user to do what you just did, right?
Yeah, exactly. So of course, it's basically usable for anyone, also if you know how to code. So it's really cool also for setting up something quickly, for mapping, for example, in between different protocols, changing data structures, for example. So it's really just a really nice and simple tool to also do something quickly, for example. And you don't necessarily, also if you are a coder, if you know how to program, so to say. And on the other hand, it's really a tool aiming basically at empowering people that don't know how to code and also closing the gap, especially what we see in between OT and IT. Because of course, what's happening here is it seamlessly integrates with how you would typically otherwise program. So we have data coming here in really via MQTT, and these are JSON objects. And also what's being generated here again is an MQTT stream. It can also be Kafka, or you can store it right away in a database. And it's just really taking all this connectivity, also or the possibility to send something there into the sheet. So in the end, for the end user, it's really just a spreadsheet formula, but what you're actually doing with it is something which you would otherwise have to code, so that there's really no gap in between IT and anybody else anymore, so to say.
Yeah, that makes sense. And we've got a question from Simon Walters. So he's asking, would it be possible to show the step to connect the inbox to an MQTT feed?
Yes, going to do that in a second. Exactly. So basically, how we get the data in, I get from that. Of course, we're going to do that. Just wanted to show one more thing right here, and that is essentially that we are right now checking the whole time whether something is okay or not okay, and then we're sending out the whole object, essentially this whole cell range. what is really cool about this right here, right now, is also that we can say, okay, I don't want to send something out the whole time. But what I essentially going to do is I gonna take this information which we have here, basically this whole if formula, and put it around this MQTT publish condition. And what's happening then is that we only send something out when it's okay or not okay, for example. So really having a control engine in here, essentially, that's calculating the whole time and just checking whether something is okay or not okay. And we're just sending out something if it's okay or not okay, or we're sending that, for example, to a different topic, because everything is dynamic. So let's say, for example, that instead of having the topic in here statically, we're going to take this one right here. It says invalid because we don't have anything in here so far. So this is going to be our topic. Right now it's still static, but let's say, for example, we're getting that with a message, which could be what we are getting in B7. And we're going to take just the right to, so let's assume that what we're getting in the message ID somehow contains already the topic we want to publish something to as well. In this case, like the three right letters. So that's essentially this. And as we have this cell also now as a parameter in our MQTT publish function, we are now dynamically also sending something out. And as I said, if you take on top of that also the if function, which we have right here, and embrace MQTT publish with that, then we are even dynamically sending out data to these different topics based on whether something is okay or not okay. And that's also just really simple here, so it can get a lot more crazy than that. But picking up Simon's question, that's essentially in the inbox, it has its own menu. So it has what we call a consumer, so data which we consume. You can tell it how it's supposed to run, so continuously, or in this case, event-driven on message arrival. And just going to show you now how this consumer is structured. There we go. It has a name, Wind Data. It's based on a connector, and it essentially has just an MQTT topic. So, and that's essentially what you're gonna have for each data stream. You see them right here on the left-hand side, and there's a hierarchy to them. So you have a connector to basically connect to like a larger system. So that's typically like a broker or another server. And then depending on what you want to do there, you have consumers or producers, and they're the consumer basically consumes the data stream and the producer produces the data stream. And they are all, in this case, like here, MQTT connector, they are based on one connector. Just go really quickly into how that MQTT connector is structured. So that's it. We have MQTT. It also has a name. There you have a URL. It's in this case just called broker, because right now I have running my local one. It has a username, password in this case. You can also have credentials or certificates, for example, and that's really the way how you then connect to something. So you have the larger connection information basically in a connector, and then based on your connector, you're going to construct consumers and producers, and that's what you essentially then going to choose right here, which makes it also quite nice from an administrative point of view, because you can have somebody who possibly understands a little bit more about the whole system, or for example is basically organizing all the access points, or just to have one person in charge of that, basically making all the connections via the connectors to different servers. And then you have later on builders who build essentially just applications, but not necessarily should be given the rights to change servers, for example, to access other servers, brokers, or systems, and they then just going to be given consumers and producers, which they're allowed to use, and within these limits, within whatever they have access to, they can basically deal with the data and build applications.
So essentially, you already have implemented role-based access control in your platform, and then you can even define scopes where a specific account or specific group can modify stuff.
Exactly.
Hey, that's fantastic. And Simon says, thank you for answering.
You're welcome.
We've got another question in the chat. What are, from David Kessering, what are the resource requirements versus stream rates? So I suppose Well, I'm not supposing anything. You
Suppose away, so to say. Yeah, I guess that's actually aiming at like streamers, how many messages and what the whole platform does, and then looking again at obviously how the resource requirements are there. And the problem with that is there's really no simple answer to that, because or as always, it depends. And it really depends on the message rate, and it depends also a little bit on how many calculations you have running in here, for example, and how many essentially of those stream sheets you have running. What we've seen is that you can really run several of those sheets, for example, here on a Raspberry Pi, also on a Raspberry 3, so it doesn't have to be the latest version or the latest edition, essentially, at cycle times. So if they run cyclically at, for example, 300 milliseconds over, well, as long as you want to. But it's really difficult to give you now exact numbers. I know I'd love to have them as well, but it really always depends quite a lot on how you basically structure the system.
So if we think a bit about what could influence the whole thing, I suppose the sampling rate for whatever sensor you have, the number of concurrent users, I guess. Is it more expensive, for example, to have several people looking at the same stream sheet versus several stream sheets in parallel accessed by various people? So can you dig a bit deeper on that?
Yeah, so it's essentially, it's not so much how many people you have on the platform or how many people you have looking at them, but it's rather about how many of those stream sheets you have running. Because now digging a little bit deeper, what you see here is one stream sheet, so that's really the sheet. And if you look a little bit closer, you also see the name Stream Machine up here. And that is really, it's just one sheet which we have right here. And you can have several sheets more. We're going to see that in a second, also in another application. And that's then really, you're essentially building a stream machine. And the stream machine is, if you look at Excel, it's like a workbook. So yeah, I can have several worksheets in there. And in the same case, you can have in a stream machine several stream sheets. Why do you do that? Because one stream machine is one microservice. And the way it runs essentially and what it does, you configure that via several stream sheets it contains. So hopefully I haven't lost you yet, but the thing is, what is one of the main calculating components here is really how many stream machines you have. So essentially how many microservices you have running on your resource, and then how the data rates are, for example. So how quickly they have to calculate. So essentially the main components are how many microservices, aka stream machines, you have running, and how much data they are essentially being fed. And the big point there is not so much how big the payloads are, but it's really rather what the frequency is, for example, of the data coming in. So those would be like the main factors. What's also quite nice about it, it's really a server application which you're building here. So for example, if everything in here is happening too quickly, my client, essentially my browser, can't handle it here, there's already like a load balance or a balancing in place, so that you won't see every calculation step, but only every second, fifth, or 10th, while still on the server, every calculation step is being calculated. You just don't see it necessarily, which if you don't have a visualization where you really want to watch a movie, doesn't matter at all.
Okay. Well, thank you so much for this short look at what's happening under the hood.
Of course. So just really also from my side here a little bit, because that's now like a very simple application which we just built here quickly. The nice thing about it is you can really also control something with it. And the thing here is it's a tool. So it's not a solution to one specific problem, unless the problem is really what we are basically doing right here. You want to build something quickly and without coding, and but in the end, it's really you have to make it your own a little bit. So as you know, they're again taking up the similarity basically to Excel, and it's a tool, and you have to make it your own and build your own solution. But that's also one of the main powerful features here. So what do you want to show you now is This is not our software here on the left-hand side. So making right now a little bit of advertisement for Factory.io. It looks like a game platform, and that's because it is, or it was, but you can also build nice, very simple production, simulations basically with that, which is always quite nice for us because we don't have any hardware. So just going to click play here, and you see that nothing is happening. And that's what it does. So you have components. You can also have conveyor belts and a couple of machines which you can assemble to an assembly line or a production line or whatever. In this case, you just really have tanks. And what we want to do with them is right now, I have another Streamsheet right here which communicates with this Factory.io simulation again via MQTT. And you see that the payload is also a little bit larger what we get from the simulation. It's just going to click play now. And you see that right now we are starting to fill the tanks. And the nice thing about it is I clicked on Factory.io before just to show that it's already there. And now the whole control over how it's now being filled is essentially just controlled by this Streamsheet here. And if you've paid close attention to what we did before, you see that this right here is essentially just data which we're going to send out. So a couple of if formulas and references, and all the magic is nothing else but essentially these are a couple of formulas, so 4x4, 16 formulas, and that's it. And all of that basically now does that, here the water levels or the liquid levels rise, they drop, and everything in a randomized kind of fashion. And then we have another stream machine, so essentially another application, and that just now to make the whole idea a little bit more complete. So we have something that's controlling the simulation, that it's going up and down, and let's just assume that this already runs, and we just want to make sense of the data for now, or of the whole process. And that's essentially what's happening, for example, now in this Streamsheet here, on this stream machine. So we are looking at the different tanks, and as you see, so the trained eye, so to say, knows that all of these, they have just been dragged in and dragged via drag and drop, dragged into the sheet essentially. And what we're doing here really now is we're just looking continuously at the level. We see whether it's being filled or not. So you see really on the numbers here how it rises or not, basically whether it's a 0 or not. And what we're doing here is really just looking at whether it starts, when it ends, and all with the idea of calculating essentially how large the batch is, which we are creating here, and what the value is of that. So let's assume we have a production line or a plant which is essentially filling tanks. We can now here look at how long it took to essentially create one batch, and also put a price tag to that, for example, and then really just store the whole thing in a MongoDB. And the whole idea behind that being, for example, that we are not always the whole day doing the same thing, but sometimes we have one liquid, another time we have another liquid, and therefore have, for example, there a little bit of flexibility and changes here. And that's essentially what we're doing here then. So process engineer basically just has his or her production line working, looking at the data, getting that in, and essentially just storing, in this case, for every production lot, for every production batch, what it actually contains, how long it took, how much it is in terms of in terms of volume, in terms of how much money is there, and then just really stores that. And at the same time, we have like a very simple visualization here over time. We have here the fill level. So if you look closely at that, the fill level is reflected there. We can, as you know from Excel, that you have conditional formatting. With us, you can actually put that on graphs as well. So as we have here, for example, different arrows, and they're going to change now basically the color, basically based on whether they're going up or down. So that's just on the side of showing a little bit of a more complex application, or one a little bit closer to real life, so to say. And why to real life? Because what we see, what Streamsheets is actually being used for is a couple of things. It's always a tool, and for that reason, it's highly customizable and always so used for the last mile or the first mile, essentially, where like a standard software doesn't work, for example. And one of these is really just stream analytics. So basically calculating a couple of KPIs which are being fed or monitored continuously, then already said monitoring. So then looking at those, for example, a little bit similar to how we did that in the first application, monitor those values and see whether something is going out of bounds. And if it does, basically create a rule engine out of that and triggering actions, for example. Another really interesting thing is really mapping from one protocol to another. So, for example, having MQTT data coming in and sending that out via Kafka and storing that in a MongoDB, or really having, for example, an application which just supports REST. So making REST requests, taking that data in and essentially transforming that into data stream. Exactly. That would be it now, almost from like the basic presentation in the sense of what you can do with it, a little bit looking at a couple of use cases. And now I'm just gonna, like, one more thing I want to show you. Let's just check out whether I've actually have that running in here as well. So there it comes, takes a second. That's a cockpit, sorry, just wanted to look actually at the windmill itself again. Gonna stop the process, it's now here. Then I'm gonna hand over to Philip, basically. You can, well, didn't want to look at that. I can show you something about the architecture. So one nice thing maybe about it as well, so I said everything is dynamic. We're right now basically looking here at something which calculates again, obviously, does that the whole time, continuously generating data here. That's what we actually before in the very first application, the simple one, used as a data source. What I want to get at now is basically what you see turning here, so the windmill. So we've seen charts like line charts, bar charts. There can also be pie charts, bubble charts, like all those typical ones. But what's really cool, you can also build very simple customized charts, for example, like this one right here. And you don't have to code in this kind of sense, because it's just going to stop it in a sec right now. Otherwise, I won't hit it correctly. What you see here is, if you break it down, essentially, very simple graphic forms. So if we go here, for example, and that's also the same way we just did the arrows, which changed colors. You can go in here and then really say, okay, I want to have a rectangle. Then we're just going to have a rectangle. But what's really nice about that is that it's essentially just another formula, which has a couple of parameters. And those are, for example, its X position, its Y position, width, height, line format, and also its angle. And that's exactly what we're using here. So we are just mapping basically the calculation back to the sheet, and that's then really just the sinus and cosine of a couple of values just to get the angle right. So that's like math from the 10th grade, and mapping that back to the sheet. But essentially, it's really just another rectangle. And as everything, the input changes, and also this formula for the rectangle is recalculated. Suddenly, if you hit click or play, the whole windmill starts to move, and basically the whole calculation and how that's done is being mapped back to the sheet and something you really did in the sheet. And that's also the same way that the errors in the application right before just changed, because another parameter is really the color, and basically whether that's above a certain threshold or below, it's just going to change colors.
And we've got a question in the chat. Is the factory.io example of input and output available to download?
No, to be honest, it's not. We could make that. We don't have any problem about that for providing this. The thing is, you need factory.io, and they have free licenses which you can use, but only for up to 30 days. But we don't have any problem with sharing basically our models or just for you to use it basically.
Okay, good. So maybe what we could do, this recording will be available on the YouTube channel of the Eclipse Foundation. So maybe if you want to share this put this somewhere on the server that's suitable for you and add that as a comment on the repository, for example, so that viewers will be able to access it.
Okay, yeah, happy to do that.
Thank you so much.
Perfect. So that's right now the point where I'd also hand over basically to the other Philip. So that's where it's getting more technical. And of course, well, I haven't done that yet. Otherwise, we're going to see each other until the eternity there. And of course, if you have any questions also, which are more to basically this part of the presentation, which we just looked at, just feel free to shoot the whole time, basically. And otherwise, just going to talk about that at the end of the presentation as well. So, Philip, just try to. So, sorry for that. Basically.
No problem. So if you hover on your own image, you will see appear a kind of toolbar, and then there's the share screen on it.
Right. Okay, so basically I just prepared a couple of slides showing you a bit details about the architecture and the technologies that we used. Mainly we use a microservice-based approach. So we have altogether 5 core services together with 3 backing services and a reverse proxy, which is not shown in this diagram here. So we have the web UI service, which contains the front end that you just saw. We have a gateway, which is, so to say, the central gateway to the back-end services. We have a message broker, which controls the internal communication between the back-end services. We have a machine service, which is, so to say, the runtime environment for the stream machines and the stream sheets. So every time a formula is calculated, every time a spreadsheet or a stream sheet is calculated, this happens on the back end on the machine service. Then we have the graph service, which controls the synchronization of the graphical object model of the stream machines. So, for example, if you view one stream machine with different users, and you enter some value in a cell, or you change the width or the height of a cell or a column, then this is synchronized between all the different users using this graph service here. Okay, then we have the stream service, which is responsible for executing all the streams, which connects actually to the different platforms like MQTT brokers or Kafka, MongoDB, and so on. We have a cache, which is basically a Redis database between the machine service and the stream service, which acts like a kind of message buffer. Right, and then we have a database where all the services store their data. It's actually a MongoDB database, and all the object models, machines, the connectors, consumers, producers, they are all stored as JSON in the database. Right. From a technology point of view, we use JavaScript, both on the front end and on the back end. So for the front end, we use the React framework together with a Material UI library, which is actually a component library for React, implementing the material design by Google. And for the Streamsheet, for the spreadsheet user interface, we use a library that we developed ourselves. It's called JSG for JavaScript Graph Framework. Right. So this is basically what you see inside the canvas area. Okay, so for the gateway service, the machine service, graph service, and the Streamsheet service, we use Node.js as a runtime, and 99% of the code is written in JavaScript. We use Mosquito for the internal broker, and as mentioned before, Redis for the cache and MongoDB for the database.
And I see the Docker icon on each and every of those blocks on your diagram. So does this mean that each and every service is packaged as its own container for deployment?
Yes, currently in version 1.4, which is the current version, we have every service packaged as a separate Docker image, and we provide a Docker Compose file, which you can start. So when you start this Docker Compose file, altogether 9 containers are started. But we plan to change this for 1.5, but I will get to this in a minute.
Okay.
Okay, yeah. Obviously, we use a lot of JavaScript-related tools for the development process. We have Jan as a package manager, Jest for testing and code coverage, ESLint and Prettier for code analysis and code formatting, Webpack for module bundling on the front end, and we use the Travis CI system for the continuous integration and for building actually the Docker images and running the tests and so on. We have different versions for Linux, macOS, Windows. We have a version for Raspberry Pi. And as mentioned before, we use Docker for the deployment and Docker Compose for orchestration of the different services. And we have also a couple of installations where we use Kubernetes for the orchestration. So all this is tested in production as well. Yeah, this is here the link to the GitHub repository. This is basically a set of more than 35 node packages, NPM packages. And this is also the reason why we choose to use a mono repository approach instead of having 35 separate GitHub repositories.
Oh.
And yeah, right. That's a problem with Node.js. You really quickly end up with a lot of packages, and it's really hard to manage them if you have multi repositories.
Mm-hmm.
So, right. And yeah, this is just a short preview to the next version, which is 1.5. We figured that it might be for the end user, it might be easier to have just one Docker container or Docker image, which needs to be started. So instead of having a Docker Compose file and several containers, and which is kind of complex for users who don't have experience with Docker. So from version 1.5, it will also be possible to have a single Docker image deployment, where we have basically the same set of services and backing services, but they are all grouped and deployed in one single Docker image, and they are controlled using supervisor for the process management. Right. But then it will be much easier to start the application using just basically this one-liner here.
That makes sense. And are there any plans on your roadmap for some kind of Helm chart or something like that in a Kubernetes?
Yes, they are on the roadmap, but not in one of the next versions.
Okay.
Yes, but they are on the roadmap. We actually, that makes sense to have Helm charts as well. Yeah.
Cool. Yeah. So they're on the roadmap, and we had it a little bit earlier on as well. But then we saw that actually the people, so we are also quite user driven. So whatever basically kind of requests we're getting there, that's a little bit where we're looking at most. And funnily, the ones that which like half a year ago said, okay, we definitely want to use Helm charts. They now changed and support now Docker Compose. So that's a little bit why the pressure behind the Helm charts has basically decreased a little bit on providing that, well, basically with the next version already. But yeah, still on the roadmap, but did a couple of features which we're concentrating a little bit more.
So given the preferences of your current customer base, and I was asking that because we have a brand new project at Eclipse IoT, which is called Eclipse IoT Packages, where we try to build a Helm chart for our various server-side components, at least. And well, obviously, a standalone Helm chart for Streamsheets could be great. And at the same time, I see the potential for Streamsheets plus, let's say, Hono and Ditto as a backend, or Streamsheets plus Cura as a backend, where you use Streamsheets as the nice looking UI in front of those established technologies. So anyway, this is something that we can discuss down the road, but I'm glad that you are at least thinking about it, and more than happy to see that happening probably next year.
Yeah, exactly. Yeah, this year we're going to see how quick we are. Yes.
Yes. All right.
Yeah, right, but I think this was it actually.
Okay.
So,
and we spoke a bit about the roadmap, generally speaking, but what you demonstrated today, I guess, is what's available right now in the platform. So what's next for the next major release?
So the next major release is essentially what Philip showed already, and that's something we're going to do this month. And that's, for example, one of the main components being there is really that you have, for example, this single container deployment. Then what you're going to have as well is that you change between something which we call preview mode. So essentially getting from the sheet very quickly to something which looks directly like not being a spreadsheet essentially, but more like a dashboard, or really not having the toolbar, not having the grid lines, just by one click, basically making that accessible. We have a couple of bug fixes, to be honest, of course. We have more support on the side of graphs, for example, in the charts, which we have. So these are the main ones which are going to come now.
Okay, that makes sense. And we've got another question in the chat. So do you see this tool as a rapid prototype tool and a config tool, or something that is used on a production basis?
I would swap the or for an and. Can really use it for both. Of course, it's really great for prototyping. That's something which we see also regularly, that people basically also to write, in this case, then more build a proper specification for what they want to actually have and get really a look and feel for how it could look like. They use it a lot. But then in the end, I mean, nothing runs better than a good prototype. So that's also what we see then, because after you've created something, there's not always the need for basically building something which you can then base on that and properly code again. Which basically does the same thing. So we see it also being used by our users in both ways. So some use it for prototyping, or, for example, for making quick presentations, like we just did that. So that's what sales engineers use it for example. But we also have it running in production, really.
Okay, fantastic. And somebody in the chat is asking if the session is recorded. It is, and it will be available in the next few hours or few days, depending how busy our creative team is, but on the YouTube channel of the Eclipse Foundation. So it's really, really easy to find. If there are no additional questions, we're nearly at the top of the hour anyway. So the one thing I would say is, obviously, I mentioned when we started, Sedalo joined the Eclipse Foundation and the Eclipse IoT working group recently, and Streamsheets is now in the pipeline as a project proposal. This means eventually the GitHub will move, that kind of stuff. But we are working on that, and obviously we will be communicating about this once this is all official. But we are glad to have you guys. It's fantastic technologies, and at EclipseCon, we are demoing. We had a nice demo where essentially we had counters counting the number of people on the Wi-Fi in various locations, and all of that was visualized through Streamsheets, and it was a very, very nice demo that was there. Yeah. I'm really excited to have you guys.
Yeah, thanks. We're really excited to be there as well. So this is really, really cool stuff. Absolutely.
Fantastic. So Philip Strauss and Philip Ackerman, thank you so much for this virtual IoT meetup. We'll have another one in January. Still working on the program, but let's say that in the, next week, something big is coming for the Eclipse Foundation in the edge computing space. So you can probably expect a virtual IoT meetup about that next year. So thank you so much for joining us this morning. Thank you to the audience and for all of the questions as well. I appreciate it. And as I said, look forward to the recording on YouTube. So,
perfect. Yeah. Thanks from our side as well. See you there. And if you have any questions, just feel free to reach out.
Yes, absolutely. Either as comments on the recording, or maybe through the working groups mailing list at eclipse.org.
Perfect.
Thanks again, and see you.
Bye-bye.
Bye.